In the last few decades, carbohydrates have captured the public's imagination, and we find today countless diet books and tips about how many carbs we should eat to stay healthy. Endorsed by celebrities and found on social media, often for promoting some dietary supplements, low-carb diets have become increasingly popular, and many people are questioning whether carbohydrates are inherently bad and should be limited. Nonetheless, although demonized by most trendy diets, the truth is that carbohydrates are the main source of energy for both plants and animals. So, basically, various tips like "cut out carbs" would translate as "cut off the body's main source of energy." From a chemical point of view, carbohydrates are molecules consisting of carbon, hydrogen, and oxygen atoms, with the empirical formula CmH2O(N), where M may or may not be different from N. So carbohydrate literally means hydrated carbon or watered carbon. Thus, from this point of view, we can't really say that carbs are good or bad, given that oxygen, carbon, and hydrogen make up over 90% of the human body. In biochemistry, carbs are known as saccharides, from the Greek saccharin, meaning sugar, and many scientists and health authorities often refer to carbs simply as sugars. This led to one of the biggest misconceptions about carbohydrates because many people, when they hear the word sugar, are thinking only about the regular table sugar. There are, however, many types of sugar, and the U.S. Institute of Medicine classifies dietary carbohydrates into 5 main categories based on the number of sugar units present. Carbs containing 1 unit of sugar are called monosaccharides. Disaccharides consist of 2 units of sugar, trisaccharides and oligosaccharides consist of 3 to 10 units of sugar, and they are often a breakdown product of polysaccharides, which contain more than 10 sugar units. As we read in the USIOM dietary reference intakes, the term sugars is traditionally used to describe mono and disaccharides. The monosaccharides include glucose, known in layman terms as blood sugar or grape sugar, galactose, and fructose, also known as fruit sugar, while the disaccharides include sucrose, which is the good old-fashioned table sugar or cane sugar, lactose, aka milk sugar, maltose or malt sugar, and trehalose. If we look at the chemical structure of these carbs, we notice that the most basic form of sugar consists of 6 molecules of carbon plus 6 molecules of water for a total of C6H12O6. If we link 1 molecule of glucose with 1 molecule of fructose, we get a molecule of sucrose. Lactose is made up of 1 molecule of galactose and 1 molecule of glucose, while maltose and trehalose are made up of 2 glucose molecules bound together. Glucose is the most abundant monosaccharide on Earth and the primary source of energy for all living organisms. Glucose is mainly made by plants and most algae during photosynthesis from water and carbon dioxide, using energy from sunlight. In the human body, glucose plays a crucial role in cellular respiration, the process through which the cells release energy to fuel cellular activity. The most demanding organ in the body that constantly needs glucose is the brain. In an average adult person, the brain consumes in its resting state about 20% of the body's energy, and brain functions such as memory, thinking, and learning are closely linked to glucose levels and how efficiently the brain uses this fuel source. Glucose is also the major source of energy for red blood cells, while the cells of the central nervous system rely solely on glucose as fuel molecules. So let's see what's happening with the carbs in the human body. As you eat the sugars from food and beverages, and I mean all the carbohydrates from everything you eat or drink, whether it's a salad or a half of an apple, a slice of pizza or just a little bit of ketchup, a glass of milk, or a sip of soft drink, so all the saccharides that enter your body, whether they are di, tri, oligo, or polysaccharides, are broken down into monosaccharides, mainly glucose, which, once it crosses the walls of the gut, is absorbed into the bloodstream. The body is designed to keep glucose in the bloodstream at optimal levels, and this is done by the pancreas, which monitors the blood sugar level every few seconds. After you eat, the level of blood sugar rises, and the pancreas releases into the bloodstream a hormone called insulin, which takes glucose out of the bloodstream and carries it to every single cell, tissue, and organ of the body. Once inside the cells, the glucose is used for energy, while the excess glucose in the bloodstream is stored in the liver and muscles as glycogen for later uses. When the glycogen reserves are full, the body converts the extra sugar into fat tissue. Besides glucose, another monosaccharide is fructose. Although known as fruit sugar, fructose is found not only in fruits and vegetables, but in thousands of industrially manufactured food and drinks. Because it's sweeter than glucose, it is often used as an added sugar in processed foods, whether in the form of crystalline fructose, high fructose corn syrup, or just as regular sucrose, aka table sugar. The USIOM lists as major sources of added sugars soft drinks, cakes, cookies, pies, fruitades, fruit punch, dairy desserts, and candy. Nonetheless, fructose is found in many other processed food and drinks, including industrially manufactured baked goods, ready-to-eat items, breakfast cereals, frozen foods, ice creams, jams, jellies, sauces, cereal bars and nutrition bars, sports drinks, energy drinks, and countless other products, most of them being manufactured with artificial sweeteners, additives, and preservatives, which are significantly worse for health than naturally occurring sugars. Although both, glucose and fructose, have the same chemical formula and, gram by gram, both have the same caloric value, truth is that all living, breathing, digestive systems, including the human body, are ruled by the laws of biology and not by those of chemistry or thermodynamics. Whereas glucose can be metabolized by all the body's tissues, fructose is metabolized primarily in the liver and only in a significant amount. Once processed in the body, fructose messes up the production of leptin and ghrelin, the appetite control hormones, leading to a reduced feeling of fullness. And because most industrially manufactured food and drinks don't contain significant amounts of micronutrients, vitamins, and minerals, your body doesn't register them as food, so you'll eat more all day long. And, because almost all the foods and beverages we consume contain carbohydrates, mono, di, tri, oligo or polysaccharides, the body fills up its glycogen stores very quickly, converting the excess of sugar into fat tissue, leading to overweight and obesity. If excessive carbohydrate intake is continued for a longer period of time, the body is getting more and more glucose. As soon as the pancreas detects glucose, it responds by releasing insulin. Too many insulin spikes cause the insulin receptors to get worn out and not function properly. Cells become resistant to the action of insulin, and the pancreas is unable to make enough insulin to overcome this resistance. Thus, instead of moving into the cells, where it's needed for energy, sugar builds up in the bloodstream, leading to diabetes. Of course, excessive carbohydrate intake is not the only cause of obesity. Besides age, meal composition and frequency, physical inactivity, psychological factors, social issues or various diseases, each chemical element we absorb, either through respiration, ingestion, or through the skin, affects to a greater or lesser extent every single function and structure of the body. In recent years, a growing number of scientific studies have confirmed that EDCs, endocrine-disrupting chemicals, have a negative impact on appetite control and weight gain. There are nearly 85,000 man-made chemicals, many of which we come into contact with every day, and only about 1% of them have been studied for human safety. Found in almost all industrially manufactured products, from plastic bottles, plastic bags, plastic cups, food containers and food packaging, to personal care products and cosmetics, the EDCs are carried by water everywhere in the environment and inside the human body. However, in this episode we'll focus only on carbohydrates, and if you want to know more about water, the universal solvent, I strongly recommend you to watch the entire series entitled 9 Things Most People Don't Know About Water, found on my channel. Avoiding excess added sugar may not be so easy, especially if you live in the USA or you frequently consume industrially manufactured food and drinks. In 2016, scientists from San Francisco, California, found that back in the 1960s and the 1970s, the Sugar Research Foundation sponsored a research project which singled out fat and cholesterol as the dietary causes of coronary heart disease and downplayed evidence that sucrose consumption is also a risk factor. As a result, even the first U.S. dietary guidelines for Americans, published in 1980, focused on avoiding too much fat, saturated fat, and cholesterol. Now, generally speaking, the 3 main ingredients that give taste to food are salt, sugar, and fat. With fat removed, food lost taste and appeal, so manufacturers added sugar to combat the inconvenience. According to Dr. David Ludwig, a professor in the Department of Nutrition at the Harvard T.H. Chan School of Public Health, overall, these processed carbohydrates are worse than the fats they replaced. Needless to say, the sugar industry profited tremendously from the uptick in sugar sales, while hundreds of millions of consumers made health decisions based on questionable information. In fact, if you are over 35, 40 years old, and you remember the taste of bread from your childhood, you can tell that the bread you buy today is sweeter than that you ate as a kid. If you can't notice the difference, is because excess sugar consumption causes the taste receptors to lose their sensitivity. And here's a simple example. Try not to eat sweets for a couple of days and drink only regular water, and then eat some raspberries. They would seem super sweet. On the other hand, if you eat the same raspberries after drinking a can of Pepsi or Coca-Cola, they would taste bland and boring. To make things even worse, new scientific studies revealed that sugar has been proved to be more rewarding and attractive than cocaine, and sugars and artificial sweeteners activate the same reward centers in the brain as drugs, triggering the release of the brain chemical dopamine. In its turn, dopamine affects many parts of our behavior and physical functions, such as mood, sleep, attention, learning, movement, pain processing, heart rate, and kidney function, among many others. That's why health authorities recommend the intake of sugars from natural sources, such as fruits and vegetables, because due to their high water content, the negative effects of fructose are mitigated. Also, when shopping for your favorite groceries, focus on the ingredients list rather than on the nutrition information panel. In most countries, the food label must list all the ingredients contained in a food product, always in the order of their weight. The ingredient that weighs the most is listed first, followed by the others, in descending order. Always choose products that contain fewer ingredients and only ingredients that you're familiar with. The fewer ingredients, the healthier the product. What's important for you to remember is that when it comes to sugar intake, you must take into consideration all the carbohydrates from all the foods and drinks you consume. For example, some commonly used sweeteners, like corn syrups, contain large amounts of trisaccharides and higher saccharides. According to the USIOM, only 33% or less of the carbohydrates in some corn syrups are mono and disaccharides, the remaining 67% or more are trisaccharides and higher saccharides. If these carbohydrates are not taken into account, the total intake of sugar is underestimated. Another very important thing to keep in mind is that the human body needs large amounts of protein, carbs, and fat to function properly, and since it cannot produce macronutrients on its own, they must be obtained from food and beverages. It's true, while carbohydrates are the main source of energy, they are not the only one. As long as you drink some water, including tea, coffee, juice, etc., and you eat something, the body has all the ingredients it needs to produce glucose because fat and protein also contain carbon. Although short-term carbohydrate restriction, for about a week or so, can result in a significant loss of weight, albeit mostly from water and glycogen stores, in the long run, restriction of carbohydrates in the diet has been associated with complications such as impairment of physical activity, heart arrhythmias, osteoporosis, kidney damage, increased cancer risk, and even sudden death. In 2019, a team of researchers from the UK, China, Greece, and Poland published the results of a meta-analysis of 10 prospective cohort studies focused on dietary information and causes of death. The first analysis was made on 24,825 participants using data from the U.S. National Health and Nutrition Examination Survey between 1999 to 2010, and researchers then applied the same methodology to other 9 studies published up to August 2018 on PubMed, Embase, and Scopus database that contained similar data to the NHANES study, with 462,934 participants, including 45,609 deaths. The researchers found that those who consumed the least amount of carbs and the most protein and fats had a 32% higher risk of overall mortality. Interestingly, in the social breakdown of participant data, the researchers noted that the majority of individuals who consumed the strictest low-carb diets were the people who had less than high school education. The more restrictive the diet was, the higher the risk of dying. 51% were more likely to die from cerebrovascular events, 50% more likely to die of cardiovascular diseases, and 36% more at risk of death caused by cancer than those who followed a diet with a higher proportion of carbs. And, if you are worried about carrying a few extra kilograms than the standards, which, by the way, are widely debated even by scientists, In the early 1980s, researchers from Orange County, California, wondered what makes people live to age 90 and beyond, and what types of food, activities, or lifestyles are associated with living longer. Initially called the Leisure World Cohort Study, in 2003 the study changed its name into the 90+ study and became one of the largest studies of the oldest old in the world. Its results were published in many scientific papers in premier journals, and researchers found that people who drank moderate amounts of alcohol or coffee lived longer than those who abstained, and people who were overweight in their 70s lived longer than normal or underweight people did. In the hope that you found the information presented in this video useful, I wish you a long, happy, and healthy life. Please don't forget to share your recently gained knowledge with your friends and family, subscribe for more videos, and, as always, thanks for watching.